है बिजली गई है, बिजली गई। लाइट गई।
என்றும் மாறாது மாறாது இறைவன் நானே இந்த சிவகாமி மகனுடன் இந்த சிவகாமி மகனுடன் சேர்ந்து நின்னடி என்றும் சேரும் நாள் பார்ப்பதென்னடி.
आणि त्या दुकानवाल्याला जर मी सांगितलं की 4 मागवून दे तर तो 4 नाही सांगितलंय ना काहीतरी.
என்னங்க Hello. Hello. Kumarvel sir. Hello. 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 Hello.
Hello, go ahead.
Hello, Kumarvel sir. Hello. Hello.
Yes, sir, you are audible.
Oh, yes, sir. Kumarvel sir, are you there? Dr. Kumarvel sir?
சார் அவர் மியூட்
சார்
போட்டுருக்காரு
அவர்
சார்.
மியூட் போட்டு வச்சிருக்காரு சார்.
Hello?
சார் அவர் மியூட் போட்டுருக்காரு சார்.
Mute போட்டுருக்காரா? Sir, Kumarvel sir. Kindly unmute, sir. Hello?
செல்வராஜ்,
Yes, sir.
குட் ஈவினிங். கருப்பசாமி, அவருக்கு போன்ல கூப்பிட்டு சொல்லுங்க செல்வராஜ்.
சரி, ஓகே, கூப்பிடுறேன்.
கூப்பிடுங்க.
Kumarvel sir, good evening, sir. Sorry, I have been to Pukot, the connectivity issue actually. You are there, is not, sir. Sir, we will start the program, sir. Sorry, kindly excuse me. Okay? Please unmute yourself, sir. Please unmute. Please. You are logged in or not, sir? You are coming inside or not? Yeah, please come inside, sir. Any issues? Link already sent to you some time back. Then you also sent a thanks again, sir. Send it now. Okay, again I'll send it, sir. No problem. I'll send it. Right. Sir, just now Sunil sir is chief sir. Yeah, please. What sir? You can take 1 hour, sir. 1 hour. You can take 1 hour, sir. Let's. Hello, sir. Kumar sir is joining. Right now he's joining. There's a talk to him. Please wait for. Sorry, excuse me for the delay. He'll join another few minutes. Yeah. Hello, sir. I sent to the mail, sir. Mail I sent you mail. The team mail. Yeah.
செல்வராஜ் ஸ்டார்ட் பண்ண சொல்லுங்க கருசாமி.
சார் வந்துட்டு இருக்காரு, ஜாயின் பண்ணிட்டு
உள்ள எப்ப ஒருத்தர் இருக்க மாதிரி இருக்கு, அத வர தெரியல.
சார் வந்துட்டு இருக்காரு.
நிறைய கமெண்ட்ஸ் போட்டுக்கிட்டு இருக்காங்க, ஆல்ரெடி டிலே 15 minutes.
ஓகே ரைட். Thank you.
Take care. Thank you.
SK சாமி அரேஞ்ச் ஆர் செல்வராஜ். ஆர் செல்வராஜ்.
మరి స్పాన్సర్డ్ పెట్టి అలా ఉంటది. అలా నాకు ఇప్పుడు మోషన్ అయింది సడన్ గా.
నీకు ఎవరినైనా
Hello. Hello, sir, am I audible?
Yes, sir, audible, sir.
Yeah.
Sir, Rangasamy sir, you are there inside. Hello? Dr. Kumaravel sir?
Yes, sir, I am audible now.
Shall we start, sir?
Yeah.
Yes, sir. Please, sir. Thank you. Happy good evening to everyone. Sorry for the delay. There is some connectivity issues are there. Is a happy good evening to everyone. Today, I welcome all the participants who have joined today to grace today's special lecture. Today's topic is going to be the materials for additive manufacturing, recent trends and the processing issues. It is going to be delivered by an eminent personality, Dr. A. Kumaravel, academic editor, mathematical problems in engineering and NAVI, and coordinator by AICT, IDEA Lab, KSRT, Dean School of Building and Mechanical Science, Professor at Department of Mechanical Engineering, KS Rangasamy College of Technology, Tiruchenkodu. And with this brief introduction of the topic, first of all, we welcome we thank our today's speaker for accepting our invitation to deliver a lecture to all our members, and also we welcome you, sir, for our platform. So we Sichamli Institution of Engineers is conducting the weekly program for the past 3 decades, and we regularly do it to propagate the latest and emerging technologies to our members, students, faculty members, as well as industry experts, and to the public at the launch. So with this brief introduction about our activities, I'll call upon our Dr. Karupasamy, our past chairman, to welcome the gathering and us to preside over the today's program, sir. Over to Dr. Karupasamy, sir.
Yes, Mr. Selvaraj. Good evening to all of you. I am very happy to participate and preside over the today's technical event, which is arranged by IEI TLC with our sister institution functioning in Tiruchirappalli complex, IAW, IWS, and ISNT, and Kumari Arivel Peravai, and IEEE. So these are all the institutions jointly organizing this today's important technical lecture with additive raw material for additive manufacturing on its processes. I am happy to extend a very warm and special welcome to Dr. Kumaravel sir, professor and mechanical engineering, who is going to deliver a very useful and very important topic for all of us. I extend a warm welcome to all the participants in the program, as well as the office bearers and the secretary of all technical institution. On behalf of IEI TLC, once again, I extend a warm welcome to each every one of you who are assembled and going to enjoy another 1 hour. Thank you for the opportunity. Thank you once again. I welcome you all. Thank you.
Thank you, sir.
Thank you, Dr. Karupasamy sir, for a nice warm introduction and also preside over today's function. Now I call upon Secretary, Honorary Secretary in the Indian Institute of Building, Tiruchirappalli branch, Sir Engineer Suresh Kumar, to introduce the speaker to the audience. Over to Engineer Suresh Kumar, sir.
Thank you, Mr. Selvaraj, for giving me the opportunity to introduce today's speaker. Good evening to all of you. Dr. A. Kumaravel is working as professor and dean in KS Rangasamy College of Technology, Tiruchenkodu since June 2008. He has completed his graduation in mechanical engineering from Government College of Engineering, Salem during 1986 to 1990. He has completed his MTech in industrial tribology from IIT Madras in the year 2004 and PhD in machine design from IIT Madras in the year 2008. He has guided 12 PhD research scholars and published more than 60 research and review papers in reputed international journals publisher like Springer, Taylor and Francis, elsewhere, etc. He has also presented more than 30 research papers in reputed international conferences. Dr. Kumaravel has received grant and aid of more than 150 lakhs from various funding agencies like AICTE, DST, ICMR, CSIR, etc. He visited Australia and Singapore to present a research paper in the year 2007. Dr. A. Kumaravel had been appointed as technical committee member for conferences, a reviewer for papers and projects, and external examiner for PhD student, etc. He is presently serving as an academic editor, mathematical problems in engineering, Hindawi publications, and a reviewer for many journals such as Renewable and Sustainable Energy Reviews, Carbohydrate Polymers, Fuel, Material Diseases, Industrial Textiles, Fibers and Polymers, etc. Dr. Kumaravel has been honored for Best Engineer Award 2016 from the Institution of Engineers India Limited, Salem Local Center in September 2016. He has also been honored with the Dr. APJ Abdul Kalam Award for Scientific Excellence 2016 in Marina Labs Research and Development, Chennai in October 2016. Mr. A. Kumaravel is the fellow member of the Institution of Engineers India and other professional societies like the Science Congress Association, ASME, TSI, SFA, ISME, and ISTE. Thank you, sir. Mr. Selvaraj.
Sir, your audio is mute, sir.
Sir, Mr. Selvaraj.
Yeah, sorry. Sir, thank you very much for introducing me, and thank you, Engineer R. Selvaraj and Engineer Karupasamy sir, for welcoming to the gathering for this today's program. I will share the screen, sir. Now. Sir, is it visible for all of you? This
Yes, sir. You are able to see it, sir. You are able to see it, sir.
Yeah.
Yeah.
So my today's topic is materials for additive manufacturing, that is recent trends and processing issues. Basically, my presentation is the basic outline of the additive manufacturing, which is used for the different material and the different techniques. Mostly, I have not covered all the techniques. Very sample techniques only I have covered, and the sample materials also I have covered, and then how it is used in the different platform, and so what is the challenges behind the material side? That is what I have presented here. So before starting the presentation, I would like to share the video, which is very basic about the additive manufacturing process. Whether the audio is audible, sir?
You are audible, sir. Go ahead, sir. Go ahead, sir. You are audible, sir. Very much audible, sir.
So this is the simple video which will explains the process of making the additive manufactured parts, and so basically the definition for the additive manufacturing process is the process of creating an object So by building the materials by layer, which will be having something like a different techniques which is used for building the layer by layer, or it may be something like melting the material and deposited on the platform where it is the product is going to be manufactured, and over the period of time. So that is what the additive manufacturing is all about. So then the process is opposite to the subtractive manufacturing. So in the subtractive manufacturing, we have the casting product, and so those products are machined using the machineries, special machineries, and then we are making the product, whatever the dimensions we required, and then we can able to manufacture through the machining process. And you see that the process which is compared with the additive manufacturing process, the subtractive manufacturing and the additive manufacturing. In the subtractive manufacturing, and we see that we have the bulk material, and so this may be something like the material is available in the form of different processes, maybe casting process, or maybe something like rolling process, something like that. We have the bulk material, raw material, and then this will be machined through the special machines for getting the required product. So this is the 3D objects. For suppose this object is to be manufactured, then we use the special machines, and then we can machine, and we can able to finally get the 3D project. You see the wastage. So through the subtractive conventional manufacturing process, you see the wastage of the material. So when compared with the additive manufacturing process, this may be a powder form, or it be maybe in the wire form, so something like that, solid form like that, and then use those raw material, and use the different technique, additive manufacturing technique, and you can able to manufacture the 3D component like this, similar kind of the same product, and the wastage is minimal. So that is what the advantage of the additive manufacturing process. Even though you have the complex manufacturing process is there for the metals, and we can able to identify, or we can able to manufacture the complex parts also through the manufacturing additive manufacturing technique without any complex difficulties. Whereas sometimes we face the processing techniques and all, so then it could be balanced for getting the complex shapes. So then this is the advantage when we are going to use the additive manufacturing process. The wastage is minimized, and you can be able to save the material, and also then you can minimize the production cost. So next. So this is a milestone of the additive manufacturing technique, and the starting from the 1984, something like the technique which is used necessarily, which is patented. Over the period of time, we come across with the different applications like biomaterial. Sorry. So this is the 1996. Then we have the first biomaterial of human tissue regeneration, and you see that the first 3D printed blood cells. So these are all some of the important milestones through the additive manufacturing process. Now we use the 5D printing also, and so the difference between the 3D printing and 5D printing is the 3D printing, you can get the three-dimensional object by depositing the layer by layer, the materials layer by layer, and we can able to get the something like this is in the extruded direction. We can able to get the additive manufacturing parts. Whereas in the 5D printing, then in addition to the X and X, Y, and Z direction movements, and also then we can able to have the rotation X and Y for manufacturing the curved additive manufactured parts, which will give the more strength when compared with the three-dimensional printer. So that is what then we can able to have the additive manufacturing parts. So starting from 1984 and till now, so this is the milestone of the 3D manufactured component. And this is the classification of additive manufacturing, and you see that it is based on the different processes. Based on the methodology, we can categorize the different process like something like based on the material, and then based on the material extrusion, and based on the lamination. So, and binding, jetting, and then powder bed fusion, and the energy deposition. These are all the different technique, additive manufacturing techniques based on the methodology, and based on the type of base material which is used for the additive manufacturing parts. Then it can be a solid, powder, and liquid form. So with this, you can have something like a different methodology to fabricate the additive manufacturing parts. And based on the so media which is used for the processing, and this may be a laser beam which is used for melting the materials and deposit it on the platform, and it may be ultraviolet rays can be passed through it. For the liquid resins, we can able to manufacture the additive manufacturing parts, and the thermal beams also, then we can use it for fabricating the additive manufacturing parts. And so in the liquid method, we have different type like stereolithography, direct light processing, and the polyjet printing. And in the solid based additive manufacturing parts is laminated object manufacturing, and fused deposition modeling, and wire and arc additive manufacturing, electron beam free from fabrication process. So these are all the classifications of the additive manufacturing process methods, and based on the different methodology, or based on the base material which is used for manufacturing the additive materials, and based on the media which is used for processing the additive manufacturing parts. And you see that from the starting, from the researchers, we can able to design, and also then we can able to have something like a geometrical design and the material design. So the geometrical additive manufacturing parts may be manufactured, design the component using the designing software. Any software we can use it. For example, Autodesk Fusion 360 we can use it, and you can use it for something like a Creo for designing the part model. And then different techniques are used for designing the material, that is the model. After that, you have to have something like a material design. Hello. Design for the additive manufacturing also. So based on these two, we can able to design and select the suitable material for that. And you have to identify that maker's movement like a designer, manufacturer, and end customer. And then we use different computational tools and interfaces for the development of the additive manufacturing material. And we can use the manufacturing tools and process development for the making of this thing, like the different type of 3D printer techniques. And the basic once it is manufactured, what is the application and impact of the 3D printed parts is, then you have something like in terms of the nanoscale to the larger scale we can use it. And from the nanoscale we use for the biofabrication, which is for the biomedical applications, and then the micro scale you can use for the electronics, and then macro scale you can use it for the personal product and automotive parts, and the large scale architecture, construction, aerospace, defense. These are all the different categories of the applications which is used for the additive manufacturing parts.
Order ID
and so this is a different kind of materials which is used for manufacturing parts, and the A materials, and the this is what we are going to see it in the forthcoming slides. And we use the materials like ceramics, and the metals, and the polymeric materials. And then we use the different techniques by using these raw materials, so then we can make the the additive manufacturing parts. So that the process maybe it is a single step additive manufacturing method, or it may be something like a multi-step additive manufacturing method, which is used for the multi-step methods, which is used for the composite, ceramics, and the metallic materials. And single step we can use it for the composite, metallic materials, ceramics, and polymer also, and based on the applications of the additive manufacturing parts. And so additive manufacturing process, it is we have the different categories. It is based on the wet photopolymerization and the powder bed diffusion technique, material extrusion, and then material jetting and wind-up jetting, sheet lamination, and direct energy deposition. These are all the process-based various methods of the additive manufacturing process. Because we talk about the today's topic is the materials challenges and future aspects. So it is only the process-based methods I have listed here. So apart from that, you have various techniques which is used. When we talk about in the classification of the additive manufacturing process, we talk about this based on the material, based on the methodology, and then based on the video also. Then we classified the different type of additive manufacturing methods. So here we are based on the process-based additive manufacturing techniques, which is presented here. The first one is the wet photopolymerization.
குமாரவேல் சார், நீங்க ப்ரொசீட் பண்ணுங்க.
Audible sir now? Is it audible now?
Yes, yes, proceed sir.
इसमें डालो एडवांस का 5 है.
Okay sir. And you see that the laser gun which emits the lasers to the targeted platform, which is the additive manufacturing parts to be manufactured, and the built platform is lowered from the top to the top to the resin, and then downwards to the layer thickness, and then UV rays, which is the light rays which is passed to through the resin, and once the light rays pass through this resin, and then wherever it is exposed with the light rays, the resin with the exposed light rays, and then it will be cured. So that is what the methodologies which is used here. And then we can control the movement of the build platform based on the layer thickness which we want. So that has to be decided, and then it has to be given as an input through the model itself. Then we are creating the CAD model, right? And those CAD model which will be imported to the 3D printer, and then we use the slicing software to create the layers with different layers in the build direction. So after that, then based on the build direction code, then the platform which will operate, and the laser light which will be thrown through the laser gun. So then you can able to have something like a curing takes place layer wise, and then we can able to get the additive manufacturing part. So that is what which is the step-by-step procedure in the photopolymerization. And the next step is next process is powder bed fusion technique. So here then we use the typically like a 0.1 mm thickness of the material spread over the build platform. Okay, and then we here also then we have used the laser gun to send the light rays, and the laser fuses the first layer first cross section of the model, which is we have designed for the thickness of the material on single layer. Once the first layer is fused using the light rays, and then the platform will comes down, and for the next thickness of the layer, and again the light rays which will be passed, and then it will be fused on the build platform. So like that, then layer by layer we can able to continuously build up to get to the final product of the additive manufacturing part. So next one is the material extrusion process. So here the wired form may be rolled in the roll, and then it will be passed through the jet gun. Here, so what we'll do is we have the heating element in this gun, and so through that heating element we can able to heat the this wired material. So for example, we use the plastic material, ABS material. then which will be passing through this melting gun, so melting jet, and this will be heated in the heating zone, and then it will emit through the nozzle, and the material coming out from the nozzle will be deposited layer wise in the build platform. So that is the technique which is used for the material extrusion. And so we have the different environment also in this 3D printer. The base 3D printer, you don't have the temperature control over the chamber of the 3D printing build platform. And if you have the next version of the 3D printer, which is having the temperature control, and then we can able to maintain the temperature inside the building chamber. So that is what we can use it. So once you have that facilities, what will happen is the finished product, the first surface finish of the finished product is good when compared with the without the temperature chamber of the 3D printer. So then you will get the good surface finish on the temperature control chamber, and the process is repeated till the completion of the final product. Okay, and the next process is the material jetting. Okay, so here you have the build platform, and then this is the build platform. Okay, and you have the jet, then you have the materials. So maybe a different materials. You have the multi nozzles here. So in this place, and so the metals, something like a printer. Then it will move in the X and Z direction, X, Y, Z direction. Then you will be able to deposit the material in the layer by layer, and you can able to get the final product. So the droplets of material which will be the injected on the built platform, and it will the curing process also it will take place, and finally you will get the final product. So the next one is binder jetting. So here what we will do is the powder is filled with the chamber. Here the powder which will be filled with the chamber, and we inject through the nozzle the binding material which will be injected through the nozzles. Okay. So then the powder is completely filled in the build chamber, and based on the CAD model, and then we receive the through the slicing software and then slicing codes, we can able to get the code, the movement of the head of the injector. Then it will move based on the shape of the product which will be built in the build environment. And so then the binder material which will be injected through the powder material. So then what will happen is the binding material which will be immersed with the powders and impregnated within the powder, and finally then you will have something like the binding of the particles, the powder particles. Then finally you will have the 3D printed object. So wherever the uncovered portion is there, still the powder is in the powder form only. Then after removing from the build platform, we can remove the powders, and we can able to get the final product of the additive manufacturing parts through the binder jetting. So this is what the principle of the binder jetting technique. Next one is the sheet lamination. So here you have the build platform, and the raw material which will be in the form of something like the sheets, prefabs. Okay, and so those sheets will be that is placed on the build platform. So then the material, again the bonding material which is placed on the surface, and then again the next sheet of the laminated sheet will be placed on the over the other layer, and then the process will be continuously in the build direction. We will follow it, and finally you will get the what is called the record shape of the model through the additive manufacturing. And so here the raw materials in the form of sheet. Then next, direct energy deposition technique. So here you have the electron beam, okay, and then you have the material feed wire, and So what will happen is the material feed wire in the wire form, it will be fed on the building platform, and the electron beam melt the materials and it will deposit on the build platform. Okay, so it is the movement is based on again on the CAD model, which will be created using the software, and they converted into the slicing software based on the slicing software, and based on the thickness what we have chosen through the slicing software, we can able to get the final product of the additive manufacturing using the direct energy deposition method. So because here directly we are melting the material and depositing on the building platform, so then we will get the final product. So these are all the different methods, techniques which is used based on the process. Okay, so for manufacturing the additive manufacturing parts. Okay, and here we are using the raw materials. So what kind of raw materials we are using, and so what is the processing techniques based on the processing, based on the application, then we use the processing techniques also. And here some of the materials which is used for the additive manufacturing parts, almost we have covered all the materials like in the ceramic category, and then smart materials, then electronic materials, biomaterials, composite materials, hybrid materials, functionally graded materials, alloy materials, polymeric materials, and the metallic materials. So these are all the materials which is used for the additive manufacturing processes to get the final product. So here the three categories I have mentioned here. One is something like the polymeric materials, and another is metal composite ceramic based materials, and then the liquid or powdered or wire or sheet, these kind of the feedstock which is used for that. So here polymeric material and the paper laminate and waxes. So the initial raw materials during the original phase of the additive manufacturing techniques, so like this is that is the raw material which is used for the machine, the additive manufacturing 3D printing machine. And plastics also then we have used for another group of material to make the plastic materials, and the metal composites, ceramics also then we can use it for the 3D printer. So this is now with latest advancement of usage of the materials. So because these metal composite ceramics, which will be a manufacturing cost is very high, and also the manufacturing time also it is high. So because the pre-processing and the post-processing of the 3D printing materials is complexity is involved, and particularly the post-processing techniques for the metal 3D printer is more. So then almost what the manufacturing time we have used, almost nearer to that we are using the post-processing time also. And so the cost of the 3D printed materials initially it was high now, and so probably based on the technological advancements, then we can able to reduce the cost of the 3D printed material, and wherever the complex parts is involved and which is not difficult to manufacture through the conventional materials, so then those complex parts can be manufactured through the metal 3D printers, and composites also we can able to manufacture it, and then the ceramics materials also can be used for manufacturing of the additive manufacturing techniques. And recently I visited the CPET, or that is the Central Institute of Plastics and Manufacturing Technology, which is located in Chennai, and they have the all kind of the 3D printer they are having, and they give consultancy activities also. That is whatever the material we want to print it, so then we can able to give the samples, and then we can able to get the 3D printed material. And almost they use they have the plastic manufacturing of 3D printing 3D printer, and metal ceramics also they used in the different form like powder form and liquid resin form. So they have different type of machines they have, that too the branded one, and the facilities can be identified in the outside, and we can able to get the 3D printed materials, because the cost of the machine is now is so high. For example, the metal 3D printer comes around 2 to 3 crores, and we can able to get the material from the suppliers, and we can able to use it for the applications. And once the technological advancements come into picture, and the price of the 3D printer also it will be lowered, and also then the different processing techniques can be modified and based on the advancements, and we can able to use like a simple 3D printer. So we can like a simple printer, we can use it for when manufacturing the additive manufacturing materials. And the raw material, so which is used in the different state forms, like maybe we can use it as a liquid form, or it may be used as a powdered form, or it may be used as a wire form, or it may be used as a sheet form. So the sheet form is used for manufacturing the laminated 3D printed composite materials. And the wired form, I think already most of you seen in the outside. So because the ABS materials, so the plastic wires, polyurethane materials, which will be in the form of wire, and then normal 3D training kit of the 3D printer also, then we use the wired form of the plastic material, and to print the additive manufacturing parts. And liquid and powder form also then used for the metals, and we can able to print the additive manufacturing parts. And the different techniques, so here I have mentioned a few techniques. One is the stereolithography. So here what the type of concept we used here is the curing of liquid using resins. Okay, so this we talk about initially. So using the ultraviolet rays, light rays, then we can able to cure the liquid resins. Wherever the light rays it will expose on the liquid resins, then it will be solidified and it will make the solid part. So it will come as a additive manufacturing part. And the laminated object manufacturing, then which will fabricate the parts by joining the seat feedstock. So this is what I have shown, that you can place the seat on the build a platform, and then use the something like a binding material, and then put the another seat over the adhesives, and then you can make it to use as a laminated object manufacturing technique. Then you will get the additive manufacturing parts. And then SLS, selective laser sintering, then the powder is melted, okay, and then to get the 3D printed material. So this laser beam may be used for melting the powder material, and it will be deposited on the build platform layer by layer technique. Then we can able to get the additive manufacturing parts. Next one is the fusion deposition method, and you can use the melting of wired material and then deposit on the built environment, and then it will be developed layer by layer method, and then you will get the additive manufacturing parts. So what are the materials which is used for the 3D printed form? And one is the polymers. Okay, so these polymers, it is widely used wherever you see that the 3D printer, then definitely the ABS material is there having, and they can, it is in the wire form, then it is fed into the melting nozzle, and then the polymeric material is melted and then injected through the nozzle, and it is deposited in the layer by layer method, so on the build platform. So then you can able to get the final products. So the fabrication of plastics, and then polymeric graded material, polymeric matrix composites, you can able to so fabricate. And so this is based on the laser melting and curing temperatures, laser melting and curing temperatures, enhance the chemical stability, and as well as the tendency to flow smoothly both in molten as well as in the softened form. And it is a common method for processing of the polymeric materials. The processing state is, it may be in the form of liquid, powder, and wire. And the technique which is used for fabricating the polymeric material is photopolymerization, and then material extrusion also we can use it for this, and then material jetting also then can be used, and then FDM technique, SLS technique, inkjet printing. And the processing of the polymeric material is somehow we can able to do it. And so this the elastomers, and then it is very difficult to process it. Okay, and the processing of elastomers is difficult in the additive manufacturing techniques. So probably what we can do is we can combine the materials like elastomers along with the polymeric materials, and we can able to fabricate the 3D material, 3D printed material, and based on the application, then we have to customize the material properties for combining of these two materials like elastomers and the polymeric materials, so that we can able to use it for the appropriate applications, and so we can able to print the component using the additive manufacturing techniques. So these are all the polymers and monomers which is used in additive manufacturing. These are all the materials. It may be in the liquid form and the polymer powder form, and then polymer filament form, and the polymer flakes form. And so these are all the different forms of material, raw material, which is fed into the machine, 3D printed machine. So the processing technique, fusion technique, is it may be optical, chemical, or mechanical, or thermal techniques, which is used for melting these polymeric materials and then injected layer by layer on the build platform. And then the printing technology. So these are all the various printing technology like multiple polyjet or SLS technique or binder jetting technique or FDM technique. So based on the application and based on the component which we manufacture through the additive manufacturing process, we can able to print the component. So based on the material and based on the fusion technique and based on the printing technology, AM technology, so then we can able to categorize it. And next one is the metals. Okay. So then the metal, it is flexible to fabricate the simple component, and also then we can able to manufacture the 3D something like a complex component of metal components. And the application which is used for these metal 3D printed components is automotive, defense, aerospace, construction, electronic industry. Still, you have the higher cost involved in the printing of metal 3D printed components. And so then we have to see and analyze the appropriate technology to minimize the cost and reducing the production of the material, the component cost. So that we have to work into all that. There are many researchers also working on the different directions to have something like a good processing technique and the lower cost of the production of productivity of the components. So that is what so the research is going on, and I am also working on that the 3D printed component. So I received 3D printed component of the Inconel 718, and then I want to work on the material characterization, that is the mechanical behavior of the material of the 3D printed material, and also the wear rate of the 3D printed material of this Inconel 718, and the corrosive behavior of the Inconel 718. Then just now it is started. So probably sometimes later, if time permits, I can able to present the results of the mechanical properties, corrosive behavior, and the wear properties, the wear behavior of the Inconel 718. And based on the Holder report, you see that in 2014, then we have the 49 additive manufacturing system sellers, and you see that in the 2016 you have 97, and now it is 49% were involved in the metal additive manufacturing systems, and there are a lot of the additive manufacturing system sellers are there, and the many researchers are working on developing the additive manufacturing systems, and so that probably over the period of time, then we can able to have something like a technology advancement on the metal 3D printers and ceramics and composites 3D printers. And there are two commercial metal additive manufacturing techniques, powder bed fusion and direct energy deposition method. So used for the metal 3D printing materials. And so here we use the raw material as in the powder form, the feedstock material, and so then we can able to get the metal 3D printed component. So these are all the materials for additive manufacturing process, particularly the metallic materials. Okay. So the metallic materials based on in the form of powder or in the form of wire or in the form of other base rock material. And here in the powder form, you see that the powder bed fusion techniques can be used, or we can use the directed energy deposition technique. And here in the powder bed fusion technique, again it is based on the laser based method or electron beam method. So there are two techniques which is used for melting the powder materials, metal material, and the direct energy deposition technique, we use the laser based technique only. Okay, so these are all the different methods which is used for the powder technique. Whether you have the metal wires, then we can use arc based method or electron beam method or laser beam method to melt the wire metal and deposit it in the build platform as a layer by layer method. Okay, so here you will give the energy input, and then the material is wire form material is melted and deposited in the build platform. So this is what we have to use the technique. The other techniques, which is ultrasonic consolidation and friction free form, and so we can use so friction stir welding also we can able to see that and the welding processes. So like that, we can use it for the metallic material also for the 3D printed components. And so these are all the classification of the methods, technology for the metallic materials. The different metallic materials I have presented here. One is the ferrous alloys. The techniques which is used for the ferrous alloys is PBF laser and DED laser. That is a powder bed fusion method, and another one is a direct energy deposition method. So here the materials used for the metallic material ferrous alloy is the grades of austenitic stainless steel, including 304, 316, 304L, 316L, ASI, and the heat treatments are generally applied on the additive manufacturing produced steels to achieve the desirable properties, and also then we can able to produce the fine grained steel component as compared to the conventional manufacturing techniques using the ferrous alloy material. And the titanium alloys, so the techniques again, the powder bed fusion method and the direct energy deposition method is used for fabricating the titanium based 3D printed material. And the most commonly used material is TI6AL4V, and so it is compatible with the biomedical applications. All the implants can be fabricated using this titanium based material, alloy based material, and it is more commonly used in the biomedical applications due to the compatibility with the tissues. And the properties are the in terms of the high strength to the weight ratio, and then it has the good fracture and fatigue resistance, and the good corrosion resistance and formability. So because of these properties, and this titanium alloys is used for the biomedical and other applications also. The other applications are aerospace, automobile sectors, and then this will be in the two form. Okay, so the titanium alloys which will have the two forms. One is the alpha phase, another one is the beta phase. And this alpha phase will have the good strength and low ductility, whereas this beta form of the titanium alloys have the higher ductility. Then you have to carefully select the material, and also then you have to select the carefully select the printing environment for combining of the two phases. Then based on the application, then we have to mix the two phases, and we have to identify the suitable tailoring material properties, and then it has to be 3D printed using the 3D printing technology. And you have to carefully select the printing environment also. So then the temperature and the other the factors. Okay. So then to achieve the required properties like strength and corrosion resistance and the ductility and porosity, these kind of material properties. So next one is the aluminum alloys. The techniques which is used for 3D printing is the powder bed fusion laser method and also the direct energy deposition method. So the other methods are ore building based additive manufacturing process also used for the aluminum alloys, and the properties you have the good strength to weight ratio, and you have a good corrosion resistance and poor weldability and low laser absorption. These are all the disadvantages in using the aluminum alloys. And so when you use the aluminum alloys, and you have to carefully use the what is called the environment. Okay, so again, so when you melt the aluminum alloys in the normal environment, the hydrogen gets entrapped, and which leads to the formation of pores during the melting processes. So then you have to specially designed zone, you have to use it close to the environment, you have to use it. So the process zone should be sealed using the additional sealing gases, and then you can avoid the entrapment of the hydrogen into the during the melting process. So that will weaken once the pores are formed due to the hydrogen entrapment into these during these melting processes, and the product can be weakened based on the strength. So then we have to be very careful when you processing the aluminum alloys using the 3D printing environment. Okay. So next one is the ceramic materials, and then you can use the suitable and economical method is the powder bed fusion method. And the ceramics, you have this higher melting point when compared with the polymer and metals, so which is a major challenge for processing of the ceramic materials using the 3D printer. And materials used for the additive manufacturing method is calcium phosphate and silicon carbide silica. So then the application is which is used for the aerospace automobile sectors. So in the development of engine and propulsion components, and also then which will be used for electronic components and microscopes. Okay, so the most advantages in the field of tissue engineering and biomaterials because of the material property, and also then these ceramic materials used for the scaffold designs. It is made up of the ceramics for the bone and the teeth. It is an integral part of the tissue engineering since the process is relatively fast in comparison to the traditional manufacturing processes compared with the casting and the sintering process. Okay, so the challenges. So finally we come to the challenges and the future responses, and what are the challenges we can face it for the additive manufacturing materials. One is the compatibility of the raw materials with the additive manufacturing processes. That is very important. And so then you have used the multi materials also. Then sometimes, and the compatibility also we have to verify it. Then it should be a compatible one. And you see that when you use the biomedical application, the material has to be compatible with the tissues, and so that is also very important. And the next challenge is the surface finish. Getting the surface finish using the additive manufacturing technology is another challenge. And the dimensional accuracy. Okay, so this is also again the another part of the challenges in the 3D printing, and the anisotropic behavior. And so when you fabricate the 3D printed parts, and so then if you have the surface finish and the built environment should be maintained in such a way that to get a good surface finish, and based on the injecting of the nozzle dimensions and the speed. So there are different parameters which is involved to control the dimensional accuracy. So that is also very important. And when you go for the good dimensional accuracy, and then the cost of the machine also it is very high. So that is also the another part of the challenges. And so if the all the parameters are involved in the 3D printed parts, okay, then we have to face the challenges, and based on the technological advancements, maybe in future we can able to overcome all those kind of challenges to fabricate the 3D printed parts. The lack of testing facilities. Okay, so once we 3D printed, and the testing facilities also, then we are in lack, and for the specific parts and the materials fabricated through the additive manufacturing route, and the occurrence of several defects in the parts. So when you fabricate the 3D printed parts, and then you have the defect in the parts. Okay, so this is another challenge. So I will show some of the challenges and defects in the additive manufactured parts. The balling phenomena. So the under surface, the under layer may be something like so not properly wetted, and then you will face the kind of the balling phenomena on the surface, and then the porosity also the another the challenge, the defects in the part, and the cracks which will be formed during the 3D printing, and that also the so this is the build direction. You see that. So the defects which is that is a hot cracks which is present in the material. So this is because of the something like the thermal gradient. Okay, so due to the thermal gradient, also then the residual stresses are present in the material, and that will lead to the cracks in the 3D printed material. So the distortion. So this is also again the another defect in the material due to volume shrinkage. Then this distortion will take place in the 3D printed components. So the other challenges are then you have the limitations on size. Okay, and so the build environment platform is the another challenge, because you have the minimum size. So probably if you have something like a very bigger machine, and you have something like 1,000 mm, 1,000 mm, 1,000 mm. Okay, so even I visited the CPET, and the machine is around 5 crore, and so you see that the build environment is like 900 by 900 by 900, something like that. So the size is another limitation, and the production speed. So that is also the challenge, and the initial investment on the material and initial investment on the machine, which is having the high cost. So that is all. This parameters also the another challenges in the additive manufacturing materials. So with this, I wind up my talk, and thank you for your patient attention. If there is any queries, if possible, I can able to answer for this. I'm also entered this additive manufacturing recently. So thank you.
Sir, Kumaral sir.
Yes, sir.
We totally enjoyed your lecture program, sir, with full of informatives. And today we understood that what is 3D, 4D, and 5D printing, and chronological development, everything, sir.
Yes,
I
sir.
got only one question, sir.
Yes, sir.
You told in one slide, two materials are being used for manufacturing the additive.
Yes, sir.
That is 3D printing. How
Yes.
the homogeneity is getting maintained, sir? It is coming in 3 lines and fed to the additive manufacturing, no?
Yes, sir.
In
Yes,
between,
sir.
it is getting mixed, sir, that raw material.
Yeah, because then use that combining of two the multi-jet 3D printer itself, it is a very complex process, because very limited machines are available. Once you choose the materials, the combining of two materials, and you have to see the parameters like a melting point and like other parameters, then closer to the another material. So that is what you have to choose the combining of those materials. So then you choose one material as a titanium, another material is aluminum, then it will not work it out, sir, because then you have two different materials, and then there will be a shrinkage, there is a thermal expansion position also it is involved. So because of all these parameters, and then you will not get the full product. So when you combine these two materials, then the some parameters very closer to the another material. So like that you have to choose. Otherwise, then the problem will come.
Yes, sir. Your answer is very clear, sir. Thank you, sir.
Yes, sir.
Thank you.
Kumar, sir, I have a doubt, sir. That everywhere, industry 4, the talk of the today's industry scenario,
Yes,
and
sir.
additive manufacturing is one of the pillars like that. People are talking so much.
Yes,
Can
sir.
you throw some light on this industry 4 with the additive manufacturing?
Yes, sir. Then, so the development, again, the technology development is, there are a lot of limitations are there when you use the 3D printed materials. So the conventional material I showed that you have to save a lot of materials after processing or after machining of the materials. And when you use the 3D printed material, then you can save the wastage of the material also. And here, then the technology involved is you are building the CAD model using the software, and then those model which is used in the slicing software, then you cut it into the different layer thicknesses, and you can use it for the 3D printing materials. So the industry 4.0, then all about the combination of the computer and the what is called manufacturing techniques. So then the 3D additive manufacturing comes under the industry 4.0. I think I hope answered your question.
Right, sir. Thank you, sir. Thank you, sir. It was an excellent answer. Thank you, sir. Thank you, sir. Participants are required to ask any doubts. They can ask the speaker. Otherwise, we can move on to the next agenda. The platform is open for questions, sir.
So because whatever the slides I have presented, it is a very basic fundamental, and there are a lot of research is going on the additive manufacturing technique, and each and every material we can talk about 5 to 10 hours, because there are so many parameters are involved in the processing technique, and it is in the modeling of the component, and also then the speed of the printing material and the melting temperature. There are so many parameters which is involved in the additive manufacturing processes, and this is only the overview and the basic technology which is used in the additive manufacturing. And there are a lot of techniques also apart from that. Here I have presented on the process based techniques. There are around 60 to 80 processing techniques are there for the additive manufacturing process, for your information.
So one more doubt, sir. That is big way. The Madras IIT Madras has found some 3D construction for the house, domestic construction.
Yes, sir.
And the civil also some big way the 3D is going on. Can you show few lines about that?
Yes, sir. Sir, this IIT Madras alumni students, they developed a machine for the construction of, I think, somewhere around 40 hours or 50 hours. I am not exactly know that. And so very short period of time, they can able to print the material. That is the building. So using the 3D printer. And again, they are working on that 3D printer of construction of the building. And the research is still going on, sir. And also, this can be used, this 3D printer can be used for the food industry also. Then printing of cakes with the different colors, so those also can be utilized in the food processing industries. And so then everywhere the additive manufacturing are coming to picture based on the technology, sir. Thank you.
Thank you, sir. Thank you, sir. Thank you, sir. And participants can ask any questions, and otherwise we can move on to the next agenda. Thank you, sir. Thank you so much, sir. Really, it was an interesting talk today. Thank you so much. We enjoyed a lot, and we also got a lot of input about 3D printing. Thank you so much, sir.
Thank you so much for giving an opportunity by the IEI Salem Local Center, so Chandra sir and Sarapuzami sir and other official members, chairman, honorary secretary of IEI Trichy, and members of the Trichy Local Center. Once again, I thank you all for giving me an opportunity to talk about additive manufacturing, sir. Thank you.
One more, two more agendas, sir. Please, a few more minutes, sir. Just okay. I call upon Dr. Kevin R. Kumar, our secretary. Hello.
Sir, yes,
I call upon our Dr. Kevin R. Kumar, our honorary secretary, to announce the next.
Let our hello. Kevin will complete his activities, sir. Then I will come back, sir. Mr. Kumar, sir. Please wait, sir. Thank you. Kevin R, you proceed.
Kevin R. Kumar to announce the
good
next.
evening. Thank you. Thank you, Silver, sir. Good evening to all. So it's. Am I audible?
Yeah, you are audible, sir.
Thank you, sir. Thank you, sir. So it's time to announce the next week lecture program. The next week lecture program will be on coming Tuesday, January 3rd, 2023. And the lecture topic is e-vehicle technology, electric vehicle technology. And the speaker is from Bharat Heavy Electricals Limited, Tiruchirappalli, Dr. Karthik, Manager, Long Range Planning, will be delivering the lecture on e-vehicle technology. I request all the members, participants to participate in this program. Also to invite your friends and other colleagues for this program. So thank you one and all. Also, it is a privilege to propose vote of thanks in this wonderful lecture program today. First of all, I thank our today's speaker, Dr. A. Kumaravel, Academic Editor, Mathematical Problems in Engineering, Hindavi, Coordinator for AICT Idea Lab, and Dean, School of Building and Mechanical Sciences, Professor, Department of Mechanical Engineering, K.S. Rangasamy College of Technology, for delivering this wonderful lecture. And it is the need of the hour because our industries are moving towards Industry 4.0. And we have rightly selected our speaker today to deliver a wonderful topic and the need of the hour topic, which will be taking our industries towards Industry 4.0 and towards IoT. So we thank our today's speaker for delivering such a wonderful lecture and to spare his time to deliver this lecture. Thank you, sir. And
yes, sir.
And we
thank you, Doctor. Yeah.
And we thank our past chairman of IE Tiruchirappalli for welcoming the gathering, and we also thank our past chairman, Dr. Yes, Karupasamy sir, and we also thank each and every one of the committee members and senior members of IEI Tiruchirappalli Local Center and members from various centers of IEI and the student members and faculty members and student members of various institutions. I thank one and all. I also thank our engineer Selvaraj sir, our past chairman of Tiruchirappalli Local Center, for hosting this program and conducting a series of wonderful such lectures. So nevertheless, we have also given the link of Google Forms in the chat box. I request all the participants to fill the Google form and we will be issuing e-certificates. So with this, I thank each and every one of you for attending this lecture program. I thank once again. Thank you, sir.
Thank you, Dr. Kevin. Thank you, Dr. Kumaravel, sir. Thank you all the participants, Dr. Karupasamy and everyone. Thank you, sir.
Selvaraj.
Yes,
Selvaraj, sir.
Yes, sir. Yes, sir.
Feedback link is correct. You send the correct feedback link.
Wait some more time.
Yeah. Please.
Topic is old topic.
Yes, sir. Yes, sir.
Please correct it, sir.
Abdiya.
Yes, Ama. program kulla link vandirukku
இல்ல சாஃப்ட் ஸ்கில்ஸ்னு ஃபீட்பேக் வந்திருந்தது குமார் இவரு
ஆமா
sir take care sir Mr. Kumaravel
sir I request the participant to fill this. We will take care of the while issuing the certificates. We will take care the dates and topic. Sir,
okay,
dear participants, on announcement, please fill the link. Though it is, you could see that the date and the name of the programs are wrong. Anyhow, this will be taken care while issuing the certificate. Please fill the link, sir.
Take care. Thank you.
I have only found out. I have informed
Mr. Kevin
but I could not
tell.
Okay, sir.
Yeah. Thank you.
Okay, while issuing the e-certificates, will correct this date and this program name, sir. Sorry.
Yes. Very good. Thank you, sir. Thank you.
Sir, excuse me.
Reshare the link. Kumaravel, sir.
Yes, sir.
Reshare the link. I am Karupasamy. Do you remember me? I was talking to you during the council member election frequently. My name is Karupasamy.
Yes, sir.
Representing mechanical engineering.
We met, sir, in person in Lee Royal Meridian Engineering.
But I could not recollect it, sir.
Yes, sir.
Sir, that I am going to give you a big presentation in the next meeting.
Yes, sir.
What is went wrong? We have not organized as expected. The program is went on, sir.
Okay, sir.
Thank you. I am going to do that. Anyhow, very happy to see you, sir.
Thank you, sir.
Sorry, I have not that hospitality committee, though I was there due to my preoccupation. I could not met and discuss in personally most of our delegates and friends and council members.
No, sir. That
but your presentation is excellent, sir.
Nagarkoil chairman, you introduced me, sir, that Riaz. Then we in the lobby, then we talked together around 20 minutes.
Yes, sir. But sometimes I may forget, sir, due to my preoccupied mind, I was talking to you sometimes.
Yes, sir. Yes, sir.
Sir, have you studied during our Professor Ramasamy period or Kumaresan period, sir?
Ramasamy, sir.
Ramasamy, eh?
Yes, sir.
Before that, my professor Trivenkadam was there. I visited during his period the college, sir.
Yes, sir. Yes, sir.
Then recently visited your college during our Vimala Rosalyn period.
Oh, okay, okay.
She was my junior.
Yes, sir.
And here my neighbor in my Kumaranagar.
Okay, sir.
Tiruchirappalli.
Okay.
Thank you, sir. Take care. Well done, sir.
Thank you, sir.
Thank you, Kumaral sir. Thank you so much. Good night, sir.
Thank you, sir. Thank you so much for giving me an opportunity. May I leave, sir, now?
Yes, sir. You can leave, sir. Leave, sir. Thank you, sir. Thank you. Good night, sir. Good night, sir. Thank you, sir.
Sir, send the link, sir. Sir, send the link, sir.
Yeah, madam, the link is there. Just fill it. There is some. There is a mistake. We will correct it. Suitably correct and resend it. There is no issue. Link is there. Again, we will post it. That's not issue.
Okay.
We will post the link.
ಅದು ಆಗ್ಲೂ ಹೋಗ್ಲಿಕ್ಕೆ
Sir, shall we close the program? Sir? Sir?
Yes, sir, we can close.
Sir, hello, sir.
ஹலோ தம்பி, கொஞ்சம் ஒரு 20 பேர் உள்ள இருக்காங்க தம்பி, கொஞ்சம் வெயிட் பண்ண ஒரு கொஞ்சம்
Okay, sir. Okay, sir.
20 participants
வெயிட் பண்ணுங்க.
Okay, sir.
ஒரு 19 பேர் இருக்காங்க. அவங்களும் வெயிட் பண்ணுங்க.
ஹலோ.
சார் சொல்லுங்க.
மீட்டிங் முடிஞ்ச பிறகு என்னடா பேசுங்க. எங்க இருக்கீங்க? யூஆர்என் திருச்சி
புதுக்கோட்டை வந்திருக்கேன். புதுக்கோட்டை மதர்ல இருந்து 1 year ஆச்சு. 1 year ஃபர்ஸ்ட் டெத் அனிவர்சரி வந்தேன். அதாவது லேப்டாப்ல கனெக்ட்.
சரி, நீங்க ஃப்ரீ ஆயிட்டு பேசுங்க. நீங்க அங்க இருக்கறனால நீங்க தான் பேசணும். எனக்கு
ஃப்ரீ ஆயிட்டு பேசுறேன்.
ஏன்னா உங்க இது எனக்கு தெரியாது இல்லையா, அதனால.
இல்ல அதான் இப்ப எனக்கு வந்து புதுக்கோட்டை வந்தனாலதான் லேப்டாப்ல கனெக்டிவிட்டி கிடைக்காம போயிடுச்சு. அதான் பிரச்சனை.
அதனால நீங்க ஃப்ரீயா இருக்கிறது எனக்கு தெரியாது. நான் அடிச்சுக்கிட்டு இருக்க மாட்டேன். நீங்க அடிங்க.
ஓகே. நான் கார் டிரைவிங் திரும்ப கார் எடுத்துருவேன்.
நீங்க முடிச்ச பிறகு ஃப்ரீயா இருக்கும்போது நைட் பேசுங்க என்கிட்ட.
ஓகே. தேங்க்யூ.
ரொம்ப இன்ட்ரெஸ்டிங். இதெல்லாம் உங்களுக்கு எதாவது ஷேர் பண்ணாங்களா எனக்கு தெரியுமான்னு தெரியாது.
இல்ல பேசுவோம். நான் வந்து இந்த டாக்டரேட்லனால வரல காங்கிரஸுக்கு.
நல்லதுங்க.
ஒரு 4 பேப்பர் ரெடி பண்ணிட்டேன். அதனால பிஸியா
நீங்க வராம இருந்து நல்லது மிஸ்டர் செல்வராஜ். அந்த சப்ஜெக்ட் நம்ம பேசுவோம்.
சரி, பேசுவோம். தேங்க்யூ.
குலதெய்வத்துக்கு இந்த இதுல போய் பொங்கல்ல நீங்க ஒரு செட்டு தாங்க உடைக்கணும் போய்.
அப்படியா? ஓகே.
இப்பவுமே வாங்கிக்கோங்க. புதுக்கோட்டையில இருந்து வாங்கிட்டு வந்துருங்க.
சரி. ஓகே. நான் இது 2016ல இருந்து எல்லா காங்கிரஸ் அட்டெண்ட் பண்ணேன். இந்த காங்கிரஸ் வரலன்னு ஃபீல் ஆகுது.
இல்ல நான் பேச விரும்பல. ஐ ரிசர்வ் மை இது வேர்ட்.
அப்புறம் பேசு.
ஓகே, தேங்க்யூ.
சார் சர்டிஃபிகேட் வருது சார்.
இது அபிலாஷ் இது
சார் சார்
அது சார் அதுக்கு என்ன சார்
சார்
பண்ண டைஜஸ்ட் சார் பண்ணிருக்கணும் தெரியல. அந்த லிங்கே இப்ப 2 வாரமா நடக்கிறது நமக்கும் எப்படி கொடுக்குறாங்கன்னு சொன்னா தானே தெரியும். இல்ல நீங்க பண்ணுங்கன்னா நம்மள பண்ண சொல்லி இருக்கணும். அது நமக்கும் தெரியாது
சார்.
அவ்வளவுதான். அதுக்காக நம்ம இல்ல அதுக்காக நம்ம ஒண்ணும்